Hi students, now we want to discuss the special cases for problem solving in conservation of momentum. In competitive exams like NTSC and JEE and all, no? Based on these concepts, some numerical problems will be asked. Now we are discussing about one-dimensional collisions only. That is, before collision and after collision, we have assumed that two colliding bodies are moving in the same straight line. But in the same, there are different possibilities. Look at the first picture. A and B both are traveling along the positive x direction. Positive x direction. Okay. After collision also, both are traveling along the positive x direction. That is towards the right. So, whichever body is having the momentum along the positive x direction, now the momentum is also positive. And whichever body is having the momentum along the negative x direction, that is towards the left, the momentum also will be negative. Keep it in mind. Now, in the first case, you see all these are in the positive x direction. So, this is along the positive x direction. This is the positive x direction. Okay. So, you look at the picture. What is the momentum of A in the first picture? Initial momentum is MA into UA. Is it positive? Okay, good. It is positive. Like that, MB into UB is the initial momentum of B. Is it also positive? So, these two momentum are positive. Before collision, the total momentum is MA into UA plus MB into UB. Okay. And this must be equal to the sum of the momentum after collision. So, after collision, the momentum of A is MA into VA. It is positive. And MB into VB is the final momentum of B. That is also positive. So, the total momentum before collision is equal to the total momentum MA VA plus MB VB. The total momentum of the system before collision is equal to the total momentum of the system after collision. All the terms are positive. Why? Because their direction of momentum is along the positive x-axis. Okay. Now come to the second picture. Two bodies are coming in opposite directions. If you roll two footballs or volleyballs or two marbles in the opposite direction, they will go like a straight line and they will hit with each other and they will rebound in the opposite direction. Is it not? Such a possibility I have taken. So before collision, the direction of A is positive and the direction of B is negative. Why it is negative? Because it is in the negative x direction. So along the positive x direction, any change is positive, and along the negative x direction, any change is also negative. So the momentum of B, initial momentum of B is negative. So what is the total momentum of the system? It is MA UA minus MB UB. Are you understanding? This is very important for solving the numerical problems. Sometimes, no, the numerical problem in your textbook also is there. A bowler in the cricket, no, he is bowling a ball and the batsman is going to hit the ball. So, the ball is coming in one direction and the bat is going in the opposite direction. Isn't it? In such cases, it will be helpful for us. So, the momentum of A is positive. Initial momentum of B is negative. So, what is the total momentum before collision? The total momentum of the system before collision is MA UA minus MB UB. This minus sign indicates that momentum of B is in the opposite direction. And this is now equal to the total momentum after collision. So, after collision, you see here, A is rebounding in the negative x direction. So, the final momentum of A is negative. So, it is MA VA with a negative sign. So, this is minus MA VA. Okay. And what is the final momentum of B? B is along the positive x-axis. Therefore, it is plus MB into VB. So wherever negative sign is coming now, that direction is along the left side, negative x-axis. Are you understanding? Good. Now the third example. For example, you see a bullet is fired on a wooden block. When a bullet is fired on a wooden block, what may happen? The bullet may get embedded into the wood and both of them may go together, so that the bullet is inside the wood. So A and B is a composite body. It is a composite body. Like that, you assume A is the first body and B is the second body. So both are moving along the positive x direction. Therefore, what is the total momentum before collision? In this case, both are positive. So MA UA is positive plus MB UB is also positive. So the total momentum of the system before collision is positive. Have you understood? Good. Now you see that both the bodies stick together. They are getting attached together. As I said, a bullet fired on a wooden block gets embedded. Both will move together. So in such a case, the final velocity of first body A must be equal to the final velocity of the second body, because both are moving together. Both will have the common velocity. And B is now called as the common velocity of the system. It is called the common velocity. Understand? Therefore, its momentum along the positive x-axis is mass of A plus mass of B, total mass, into common velocity V. This will be very frequently asked in many competitive exams. Be thorough with this formula, and all the three also are very, very important. So once again, I am recalling that whenever a body is moving along the positive x-axis, its momentum is positive, and whichever body is moving along the negative x-axis, its momentum is negative. And all the three special cases, I hope you must have understood well. Fine.